Hey y'all, I'm Kyle Boutette. I'm an engineer at Cloudflare working on our Stream product, which is a full-service VOD solution. Today, as you know, the slide might say, we're going to be talking about edge delivery for, edge compute for video delivery. So we've been using this in production for about 3 years now, the entire lifetime of the product, and it's let us ship a lot of hard features surprisingly easily. For us, it's a core primitive, and it's worth sharing. But before we dive into edge compute, it's really useful to get a shared context of video delivery in general, because it turns out video is hard, video delivery is hard, and we got a good spread of people here. So let's start simple. All right, so we start simple. Everyone in this room could set this up in 5 minutes. We have a player, it talks to our server, it fetches part of a big ol' MP4. If you want to get fancy, maybe you use Dash or HLS. Cool. This works great. If you want to scale it, you add more servers. Everybody's happy. But something bad happens in that you start doing a lot more server management and a lot less cool video stuff. So we can reset this scenario and pay someone who can do this better than we can. So we put a content delivery network in the middle. We have our player talk to the CDN. We have whatever requests the CDN doesn't have get sent to our server. Easy. So this is pretty close to reality. If you just want a VOD service, you're done. Even for live, this will scale pretty hard. But now there's a problem. If we want to do things beyond just that, we have to recognize that we've ceded a lot of control to the CDN. Instead of our server getting every request, now the CDN does. So if we want to treat requests differently based on some part of it or based on a user, then we can't. So let's call those features dynamic, and here's a whole bunch of them. These are all problems we've had to solve at Cloudflare and are in the process of solving. And there's a lot, it turns out. Video is also hard. So how do you implement these? Well, like everything else, you implement them by running code. And if you're running code, you have to run the code on something somewhere. So where? Well, there's 2 places you can run code, right? There's the player or the server. Thankfully, in the last 2 hours, you've been told that both of these are kind of not great. So I can I got an easy job here. So the player is client-side software. If you want to have multi-platform support and you want to do something really fancy, you have to do the same thing across web, Android, iOS, OTT. It's not fun. You can do some stuff, but a lot of stuff is going to be painful. So OK, we have the most control on our server, so we send the request to the server. It goes through the CDN. We get little to no benefit from the CDN. Not good, because the user experience is now a lot worse. So that means we have to trade off having a lot of complex client code versus having a bad user experience. And this is reality. We've been engineering for a long time around this assumption. A great example is the transition from RTMP to HLS. You can scale RTMP, but because it's so stateful, it's a lot harder than just Dash, which is stateless. OK, so that is the baseline. And you're waiting for me to get to the point. I'm wearing the shirt from the company that has a big content delivery network, and I've ignored a third of this diagram, so let's stop ignoring it. So edge compute means you run code on the content delivery network. So in the request path, you run your code such that it can hit the cache, which is really fast, or it can go around the cache, which is slower but still fine. More on that later. OK, there's a spoiler here, though, and it's that if you work at YouTube or Netflix or Cloudflare, you can already do this. There was a Demuxed talk last year where a Twitch engineer discussed their playlist tailoring service running on their edge. So OK, this isn't a new idea or a paradigm shift. It just has a really high bar to entry because you need to own the entire content delivery network. So do I end the talk 5 minutes in and say, well, that sucks, go build a CDN or buy one? No. no, I don't want to leave you all unsatisfied. So turns out we can use everyone's favorite piece of technology. We can use JavaScript. OK, so JavaScript is easy to isolate from an operational perspective. And there's a bunch of products now, Cloudflare Workers, Lambda at Edge, a bunch of tiny startups, one of which I learned about yesterday at the speaker dinner, that offer the ability to run JavaScript in the hop path. So you can run your main.js in front of the cache. It can be fast. You don't need to involve a server. And everybody's happy. But you want to see code, right? Like, I can't just tell you ideas. So here's code. It's a one-liner. It looks surprisingly good on this display. And this is the entire request-response flow. So we take a request, we make a response, and we return in the body of that response the request's URL. Easy, trivial even, but it's one line. Let's try some more lines. So I said more lines. This is 3 lines. We can do authorization. So we can take a request, look at some part of it, maybe a header, maybe a cookie, maybe part of the URL, and we can decide if it should continue or not. Let's get more concrete. Stream has a feature called signed URLs. So we take a cryptographic token, a JSON web token, in the URL. We parse it out, and we validate it. At a high level, it looks something like this. So I'm going to step through this. You don't need to read. You parse the URL. You get your token. If you don't have a token, you just can't validate it. So you say, no, this request is not OK. Then you talk to your server to fetch a key that was associated with that token. And then you validate the JWT or your token with the key. Cool. 5 lines, and you've done asymmetric cryptography and solved a hard problem. But I just said you talk to the server. And I spent 5 minutes saying don't do that. So what's up? It's fine, though. We're still fast. And the reason is caching. So the video.m3u8 here is cacheable. We can say, OK, put that in the cache, and we're fine, because the signed URL acts as a cache buster. But even better, the sub request to our server for that key can be cached. It's a little request going to our server and back. So that's pretty good. What's it look like for other features you might want to implement? Well, back to the scary list. I've stubbed out a few. If you want to render HLS on the server, you can just take some metadata and turn it into a manifest. And yes, I just skipped a couple steps, but it's really just string templating at the end. If you want to do transmuxing, the awesome Video.js people already did it for you. You import mux.js, and it's 5 lines, and you're done. It's not bad. It's not bad at all, actually. OK, so edge compute. To wrap up, it's really powerful because it's just one more place to run code. And that's pretty good. Instead of summarizing a 10-minute talk, it doesn't really make sense. Let's have some more code. So we're the CDN now. We're going to take full control. So in this code, we're going to take a request. We're going to check the cache. If the request is in the cache, we're good. We return the response. If the request isn't in the cache, we fetch the resource, we put it in the cache, and then we return the response. Now, that's exactly what the CDN does. But now we can do whatever we want, wherever we want. Cool. So I have to mention that most edge compute providers have a really sweet free trial option. Cloudflare has one at workers.dev. And last thing, absolute last thing, if you like to remember talks based on memes, I'm sure this isn't going to render well, but here you go. OK, not bad. Cool. So yeah, you get 10 seconds of memes, by the way, because of the clock. So I'm Boutette. I'm an engineer at Cloudflare. And thank you very much.